Hi, everyone.
Welcome everyone. Welcome on this Thursday afternoon. It's really nice that you're watching this live stream of our data engineering meetup. Well, at ING we love data and we love knowledge sharing. So that's why every month we host our monthly meetup. And this month it's time for the data engineering meetup. So Samantha and I are your hosts for this time. So Samantha, maybe you can shortly introduce yourself.
Yes, hi, this is Samantha Burattini. I'm from ING WBA, and I'm very pleased to introduce 4 amazing speakers that we've got this afternoon.
Yes, and my name is Jessie, and I am part of the ING Analytics team. So indeed, Sam, what you're already mentioning, we are having 3 amazing talks, 4 amazing speakers from this time actually from Poland, from Turkey, and from the Netherlands. So very international. So thanks again for joining, and we are really excited. Yeah, so I think it's time for our first speaker then.
Thank you, Jessie. Our first speaker, our star speaker, it's called Annie Mergedumian, and she's a development engineering from the payment tribe of ING. And Annie, she has joined ING for a year now as a developer engineer, and before that she has worked as a software engineer for more than 5 years in a fintech company. Her academic background is focused on a combination of software and artificial intelligence. Annie holds a professional doctorate in engineer degree in software technology from the Technical University of Eindhoven, with a focus on a combination of artificial intelligence and software. She loves reading books and singing, and she loves to play tennis. And her presentation title is Process Mining Explained by a Use Case in a Semiconductor Domain. The floor is yours, Ami.
I just wonder if you hear me and see my screen. And so I will start the presentation, if so. So good afternoon, everyone. Ani here. So as Samantha mentioned, I'm going to present process mining explained by a use case in the semiconductor domain. So today's presentation, I will go through what process mining is, process mining benefits, process mining algorithms, tools, use cases applied at ASML, one of the leaders in semiconductor industry, conclusion, and references. Well, starting, I want to tell about myself. I am Ani Mergedumian, originally Armenian Iranian, currently based at Amsterdam. I hold PDN of professional doctorate in engineering and software technology from Eindhoven University of Technology. Maybe you wonder what PDN is. It is a postmaster program provided by 4 technical universities in the Netherlands. And the main focus, the second year, is a personal project, which in my case, I did my project at ASML, which is based in Veldhoven, Eindhoven. And today I'm going to give a case study that I did in my final project there. I have more than 6 years industrial experience, and mainly in fintech, currently a software engineer at ING for a year now, with a huge passion towards data. So, all right, let's get it started. What is process mining? Process is a collection of discrete activities or events performed in order to achieve a certain goal. One of the main people, which is known as to be a father of process mining, is Professor Lil van der Aalst, who was a professor in Technical University Eindhoven. Currently, he is in Aachen. by his definition, process mining is set of techniques used for obtaining knowledge and knowledge of and extracting insight from processes, and it's data driven. So you have collection of the data, you have the logs, you analyze them, and end goal is to discover, model, monitor, and optimize the underlying processes. And process mining is considered as intersection between data science and management science, because management people can bring the processes into the picture, and data science people can have the statistics, analysis, collecting data, and so on and so forth, which might you guys know more. But how are processes modeled and represented? So I'm going to quickly tell you the ways that a process can be shown. One of the ways is PetriNet, or place transition networks, which shows piece and piece here, and it can show from one action the other action can achieve, and so on and so forth. And the next way is Gantt chart, which management people might know more about this. So it's a timeline, and the tasks are on a cascading order, shows the way they're proceeding, basically. And two newer way to show or represent or model the process are UML, known as Unified Model Languages, and specifically activity diagrams there, which we can show activity, conditions, forking and joining and starting and end of a whole process or activity there. And the other one is BPMN, which stands for Business Process Modeling Notation, which has event, activity, gateway, and connections there. And all of the combination here are serving to show the processes that are happening in the into a specific system, environment, and etc. But what are the benefits of process mining, or what are the poles of process mining? Again, according to frontline people in process mining, first of all, it is process discovery. And basically what it is doing. So we are starting from event logs. The process mining techniques allow describing and modeling the actual processes that are being run in a system. And in the end, by process discovery, a model of the activities in a system are achieved. Second profit is conformance checking. And as you can see, with detailed documents, there are models which are already provided to any system. An application of process mining allows identifying their conformance and with established compliant procedures. In this way, you have a model, you have an event log, and you want to check if it complies to the actual model, the as is of the system, like the logs of the system, which are already there. I will dive deeper into this. So if you have any questions, you can keep it in upcoming slides as well. The third pole is enhancement. So consider that now you have a diagnostics, and again, with the event logs and the model that you have, you already discover what are the bottlenecks in the systems, what are the points in the system that are decreasing the throughput, like making processes late and latency. In other words, going one by one through all these three poles. So process discovery as the first one, I want to show you in a more graphic way. So consider that you have a data, that you have logs, and it is sorted by timestamps. So if you have some cases, per se, let's imagine a banking domain here. So you have a customer, which is your case one, and in this picture is depicted as a green rows here. So this customer or case one is doing activity A, and then B, C, D, and E per time. And if you want to do the same analysis, it can be depicted as A, B, C, D, and E, and so on and so forth with case 2 and case 3. So if you want to see the one model and what is the process discovery, you need to come across one network, one modeling tool, which can be BPMN, as I showed to you, etc. So you can see like all the cases started with A, and all of them finished with E, and with D. So this action is called process discovery. Basically, you discover what are the sequences of actions happening in your system. And the second one, conformance checking. This picture might be familiar for people, especially people who are living in Netherlands. And in pavements, so many times you see that there are poles put here, and it is designated for pedestrians to pass through it. So if you consider in the literature of process mining, this can be a model which expect users to not pass by the bikes, but walk through these poles. But in reality, you see the grosses here are putting a path. So reality, you can say, okay, this is deviation from what model we have. So conformance checking in real life, it is doing some checks like this, like what we have as a model, and in reality, because we have the logs there, what we are achieving there. And in other schematic view, if I want to tell what exactly process mining concludes, let's start with the logs in a center of this picture. So as I said, process mining is data driven, and everything starts with event logs. So event logs, as I said, we can go through, discover the processes there. So we can have via some algorithm that I will go through them quickly in this presentation as well. We discover the processes, and from that, this is as is, because it's exactly coming from the event log. Then by applying some performance mining, we can go through performance charts and how the system is actually doing per se. Some process might take longer, some process might not be faster, etc., so on and so forth. And on the other hand, business people or experts of any system can come to the picture and bring the business rules there. And by this to-be process mining or ideal way, as I depicted the previous slide, like in a pavement, we can compare with the actual activity that the user is doing, and this is called conformance checking. And from conformance checking, with respect to event log prime, which is another set of logs, we can come across the differences, deviations, diagnosis, and etc. So this whole picture depicts what process mining can serve to any system or any domain. So what information is needed? Basically, for any sort of data related process, we need preparing the data. So in our case, it is logs. But how exactly, what exact fields we need to apply process mining? There are, again, 3 poles here, which you might already guess about it. So first of all is a case ID, which is a unique identifier of an entity going through the process. What does this mean? In a hospital example, the case ID can be a patient going check into hospital, going to specific diagnostic, going to I don't know, drugstore, etc., etc. So a unique identifier, and in bank it can be a customer, which customer ID isn't unique enough. And an event, which is the sequence of activity or processes that we want to analyze on top of it. Again, it can be opening an account, depositing, or in a, again, hospital case, it will be every single action that a case or a patient can perform. And of course, once we are talking about processes, time or sequence of the actions come to the picture, which is the timestamp, or if we are not sure that we have the exact time of performing a specific activity there, at least we need to know the sequence of actions there. I want to talk a little bit about the algorithms of process mining in the next topic that I want to talk. So these algorithms, like any other machine learning or artificial intelligence algorithms, they are processing or they're analyzing a set of data, and they're producing some output out of it. And because in this field, most of these algorithms are called basically miners. So alpha miner, which is one of the oldest miners, basically for all of these, more or less, they are getting the log files, which have the specific qualities specified, these three poles that I already mentioned in previous slide, as an input. But as an output, Alpha Miner produces PetriNet with initial and final marking. So it says that this set of actions started with this process or activity and ends with that specific activity. And frequency of the event, which specifically mentions like 50% or this number out of the total cases followed this specific path. When we use Alpha Miner, it always generates results. So you can always use it, but it's not promising that it will always give a good result, but at least it will give good insights from for the log existing. Heuristic Miner is another and more advanced miner, which as an output, it produces heuristic net, and again, it can be converted to the Petri nets. This algorithm, with the way it can be used for the cases that we have too many cases. So in real life logs, whenever we have different events, we can use heuristic miner, and it can exclude the noises and abstract it in a better way that decrease the complexity of any system. And the fuzzy miner, as the name comes in, it produces fuzzy model, and it is good for, it uses significant correlation metrics to interactively simplify the process as desired level of abstraction. It is one of the newest algorithms, just emerged in 2007. And the fuzzy model cannot be converted to other types of processes like the previous algorithms that I mentioned. But the best thing about fuzzy model is that you can animate through it. So you can see actually how logs are flowing. For process models, like any other data science-related models, that we have some metrics for evaluating how good an algorithm is behaving. We have the same criteria, more or less, but in different, it looks at the problem in a different perspective. Remember what I mean by precision, recall, accuracy, etc. So the metrics in process modeling can come across fitness, which quantifies the extent to which the discovered model can be accurately reproduce the cases recorded in a log. Precision shows the proportion of the behavior represented by the model, which is not seen in the event log. Generalization assess the extent to which the model will be able to reproduce future behavior of the processes and can be seen as measure of confidence in the precision, basically. And structure or just simplicity of the model captures the complexity of a process model in terms of readability. So how readable any model is. An argument point, we can argue that we can say for each event log, there is just one process model, just one best process model, but this is not true. Because again, likewise, the per se clustering algorithm, one can say, okay, k-means here acts better, or I don't know, BPM, other algorithms can perform better, but it depends on the different views, different modeling language, different mining algorithm, and different levels of accuracy. So you cannot say that the model is always the best. It depends on these views. But going to the tools for the process mining. So we don't want to reinvent the wheel. There are already good libraries that you can actually use is for your logs and your systems if you want to apply process mining. And I know Python as one of the most used languages, library called process mining for Python, which is PM4PY, which is basically is an open source. And recently, in the recent 1-2 years, the group has started to build Flask integration as well, which is I think it's with a little bit of a payment you can get the libraries. In R lovers, we have process map R within the VPAR packages. And software that actually I used, and it is intended more in academic usages, and it's free, and it's written based on Java. It is called Prom, and it is produced initially by, again, Technical University of Eindhoven under supervision of Professor Van der Alst. And the interesting part about this tool is like for each academic purposes, you can add a new component, which each component can have new algorithm implemented, but it has already too many algorithms implemented. So you can simply download it, install it, and play around with your logs. And then the spin-off of Prom, which is Disco, abbreviation by Discovery, by Floxicon, which is a commercial version of sort of Prom. And again, with a highly supervision of scientists, which have process mining experience. So again, I think you can use it free trial for smaller data sets, and it's commercial. And for all of these tools and libraries, the input is simply CSV files or XES format file, which XES recently became is an XML-based language, extensible event stream, and recently became as a main tool, main format for process logs, basically. And next, I want to go for the use case. So at ASML, which is one of the biggest and market leaders in semiconductor industry, which is a Dutch company, as you can see, TwinScan is one of the oldest, most important, and biggest machines there. And from the name, it has twin, like two stages, which a wafer, which as you can see, circular plates come here. In for one side is a measure side, and the other side is an exposure side. And measurements are done, and then the plate or the wafer is transferred to the other stage, and the image is exposed on top of it. This is a really simplified version of what is going on there, but the components basically there is, as you can see in this diagram. And because all the process there is automated and done by robotic eyes and robotic arms, and all sort of engineers are working at the same time to produce images reflecting a nanometer precision, processes are really, really complicated. So it's not always complying to this cycle, because sometimes measurements can go back and forth. Long story short, by the running of whole machine, a single one of the logs which is generated is machine diagnostic log, which is a flat format file, is generated for the whole machine run. But this log file is unique enough to have a tag for each specific action on top. By action, I mean it can be starting of a measurement, starting of a exposure of the light, starting and ending, or a specific measurement amount there. So consider that the unique action here is the specific tag. So in this slide, you can see I deliberately blurred this, because these columns, you can consider it as not important columns, but you can have tags, you can have unique identifier for the case you have, and you can have a sequence. So this is the job of process miner or process scientists, who differentiate what hypothesis they want to achieve, and determine which columns should be these three poles that I've already mentioned. So in this case, the case ID is combination of wafer, which the circular plates you saw in the previous animation, and the job unique ID, which is the start of the action. So combination of these makes the case unique enough. And the tag would be the activity, And the sequence is a sequence number, because here we are talking about nanoseconds here. And the purpose here was, yeah, different purposes can be achieved by process mining. Like, what is the bottlenecks there? How is the machine behaving on the case of for errors or for making a precise pictures, etc., etc. So initially with the prompt tool, I converted the CSV file to XCS. These screenshots are from the prompt tool. And then, as you can see, you specify exactly which columns are your case and which colors are your event, basically. So I specify it, and I did these steps, which are generic enough that for any other data or any other use cases can be used. So constructed event log with a lot of pre-processing, we get to a data frame that can be used for process mining. Inspected data, so prompt tool provides a good inspector for showing the number of cases, the number of activities, or even the chain of events. In my case, it was the tags or the activities that were happening one after each other. And you can see it has a good percentage how many times a specific thing happened after the other thing. And then I use the fuzzy model per se, and for a very small subset of the actions there, I come to a diagram like this. And I said in a previous slide that fuzzy model, I can animate it. So I'm going to show you the animation of the process that it is there. This is all done by prompt tool. As you can see, so it shows a start action and how the activities are going on. And as you can see, the thickness of the line shows the higher number of the process transits from one state, or in my case, from one tag to the other one. So this can give a good insight from any domain that you're working on. In continuation, so I talked about alpha miner. This can be one result of alpha miner, again, showing how the transition of the states were going on. And directly flow graphs are another way to show. And as you can see, it can even show the green ones are starting states, and the red ones are the states that are finished. So a job that started in a machine mostly starts with the specific tags. And again, here you see the frequency of actions that happened and thickness of the lines there. But I just want to say that in complex domains, this huge process graph that you see is just 1/40 of what is actually happening in the domain. So this way we can come across a better analysis and improving and figuring out the bottlenecks and improving the throughput, which in this case it is in the scale of nanoseconds. So, conclusion, process mining is a great chance to take control of your data and start making better decisions based on the facts, because we are coming from the data than the intuition. And it can help in any case, in any domain that you even cannot think about. So it's detecting issues, it strengthens the operations. It prioritizes cost-effective action. So you can see, like in a banking, in which sector or in which process place the most time is wasted or the most time is consumed. So you can suggest how you can improve it. Then you can reduce the throughput time and increase, in the end, customer satisfaction. By customer, you can even mention stakeholders, because like in ASML case, it is end customer, but the stakeholder might be even people who are working in the same team. And if I persuaded you enough to like process mining and go through it, as it is really trending for any businesses, I would suggest to go through this book by Professor van der Als, Process Mining Data Science in Action. And there is a corresponding Coursera course by the same person, which himself is presenting about the details of algorithms and how you can be a process mining scientist, basically. So this was from myself. Thank you. And yeah, you can find me in these links. And if you have any questions.
Annie, thank you so much for your amazing presentation. Now we know everything about this domain. I've been overloaded by messages, and people from my tribe also are telling me that finally they heard something about it. But there are two questions already in the chat from Vasily Orlov, and he says, if, say, 100 people are doing a process in 100 slightly different way, how do you unify the process model? That's the first question. Go ahead, sorry, then I'll tell you the second question.
Yes, so as I mentioned in one of my slides, there is not only one way to say that if a model is correct. So you can argue what is the goal if different people are doing it. Either it is who is the customer, what do you want to improve by applying it. So again, it's like a machine learning problem. So you have a hypothesis and you want to validate it.
Yeah, indeed, because his second question is about machine learning. So have you looked into machine learning ways of discovering the process model?
Yes, so this is one part of the project that I did, and the output of these were actually fed into the machine learning. So yeah, because today I just cropped it to this version, and indeed you can do it, and you can.
The last speaker of us, which is our fantastic Damian Warszawski, and is our chapter lead of data engineer in Poland, and is from our tribe, so the WBA tribe. And Damian has a long and rich industry experience in software engineer and gives him an intimate understanding on how to create valuable software product for business operation, continuously passionate about learning new things and always to discover the cutting edge to apply in a current organization. As a part of our tribe, his main focus has been on building ML platforms to productionize models and improve productivity of data analysts and data scientists while interacting with data. He's married with two very, very naughty children. It's called the Two Destroyers Under 4. He loves kite surfing, and of course, is the most important one is the open source committer for the Apache Atlas. So the floor is yours, Damian. Good luck.
Okay. Thanks for introduction. I hope you can hear me well. So it's a great time to talk about MLOps and ML infrastructure. So MLOps recently gained a lot of attraction, and some people claim that MLOps is the future of machine learning. And yeah, that's a few words about agenda for today. So I would like to present a state of art of enterprise ML. I would like to talk about challenges while moving to production, and then a short case study coming out from our experience in wholesale banking advanced analytics, including best practices and tooling for MLOps. So a few words about us. As a DAP team, and a model management, we are focused on building the model management capabilities inside the data analytics platform. And in the end, there will be like a short demo for the tooling part, and you can basically reproduce the examples which will be presented using this GitHub repo. Okay, so talking about enterprise, machine learning has no value unless related to some business process. So about the use cases, literally hundreds of problems that ML can resolve. And here is quite recent study from Algorithmia presenting a different application of machine learning for different business domains. And that basically shows how business evolve over time and become more diverse in a context of machine learning products. So from most obvious one like the recommender system to the less popular ones like trying to build the long-term customer engagement using the AI. Um, uh, Here a little bit different perspective, but from the same research. So it becomes even more interesting if you look at the maturity levels. So here is the graph representing the state of enterprise adoption and success rate for machine learning projects. So going from the left, you can notice that a lot of them are on the early stage, and as we are moving to the right, it's going through the evaluating stage, as to the production grade deployments, where we actually have like only 8% of the matured solution in production. And that highlights two things. The appetite to apply ML grows recently, and deploying to prod is a quite challenging task. So I will rephrase the popular statement that not every model survives the contact with reality, and ML is still more about experimenting. So it is expected to not deploy like 100% of the models to production. Now the different benchmark, it reflects a state of AI from any perspective you can imagine. It is coming from state of AI organization, and you can and it's really insightful. So the authors of this report notice a general trend in industry which focus on running models rather than just doing the research in ML. And it's emphasized the growing interest in ML operation by means of the fastest growing GitHub projects and traffic on the Google search for the term MLOps. So you can basically notice, for example, iterative DVC or Cortex Labs Cortex, which is essentially a solution, open source solution for deploying the models. And the insight is that MLOps is relatively new term here, and the interest is growing. So now a couple of slides on challenges while moving to production. So going quickly with the basics of continuous integration and continuous delivery. It is well-defined procedure for software development. It is quite mature, and it's about wrapping the automation around building the software products. So basically, you develop your code in your favorite notebook or IDE. You run the tests, merge it to the source code repository, and then essentially the CI/CD process would initiate a build and would take all of your code and create like a single assembly from that. And eventually that will be deployed on the target environment. So continuous integration is usually decoupled from the continuous delivery by the means of the different frequency and schedule of the process. And the artifacts that are built during the continuous integration phase are essentially deployed on the target environment. So once the build passes all the tests and all validations are in place, that artifacts can be promoted to the appropriate environment, like the production one. And that proved to be working and be an effective way of structuring your project. And so traditional CI/CD process has been around for the decades. So why not apply this within the landscape of data engineering and data science? So basically to adapt at different stages of ML project to fit the CI/CD process. Essentially, the switch is about, when it comes to the code, development is centered around notebooks. We need to have ability to track experiments, runs, hyperparameters, metrics, different versions of these artifacts, and anything which is essentially the outcome of your run. For the build process, so machine learning pipeline is about training the model, which is going to happen at scale. And with your new model features and a set of hyperparameters, you can basically apply it effectively. As you have the process in place, you can basically you could probably basically can track your different model versions using the dedicated model registry. And that's about continuous integration. The outcome of the continuous integration is we are going to release the artifacts, which is the outcome of a typical CI/CD pipeline. But release in machine learning products could be a model. It could be like entire pipeline or kind of a Docker image or entire code, depending on what is required on a downstream side. So for continuous delivery, while talking about data engineering or data science pipeline, the goal is to schedule regular jobs. On the other hand, that can be also a real-time serving, so doing the real-time predictions. So the last step is about operations, which are even more complex, but I will be talking about it on the next slide. So a lot of things can be leveraged from the software engineering, but with additional complexity on top. So traditional programming is quite predictable and testable. We can verify our requirements on the code side, while machine learning has this property of having unclear success criteria. So basically, data scientists working to set up the objective functions and scores which needs to be evaluated. And there's this there are these nice Google papers. I will present the link in the next slide. That states that ML systems have this special capacity for accumulating technical debt, because all of the maintenance problems of the traditional code, plus having an additional set of ML specific issues. So the debt exists more on a system level rather than the code level. So referring to the major complexities, so machine learning is a data-driven approach, and data influences the ML system's behavior. And these are the things which were mentioned by Google. This paper have a couple of years, but I think it's still quite valid. So just to name a few of these complexities, for example, entanglement. So that means that no input is ever really independent. So changing anything actually changes everything, like changes in prediction. The second thing is about data dependencies, which cost more than the code dependencies. That can we can think of the unstable data dependencies. So the input features are unstable. We expect to have data drifts which occurs over time and happen in an implicit manner. That data may come from the different systems which may be corrupted. The other thing is underutilized data dependencies. That means we can have like a legacy features, and this redundant features can go undetected for the process. We can have a bundled features, so features which are bundled together and possibly including the one which has no value or just add a little value to that, or the correlated features. That's about it. And there's also this kind of the anti-pattern, which is called the dead experimental code paths, to perform experiments with alternative methods as a conditions within the main production code. And the cost of this on the experimenting side is not so big, but on the surrounding infrastructures, that needs to be reworked. And the last part, which is actually my addition to that, is lack of explainability. So explainability essentially bring confidence and value to clients. It expresses how the model works, and is a major way to debug it. And there's European Parliament published. So European Parliament just published a draft regulation on AI, and it also includes the explainability as kind of a requirement. Okay, so imagine that that iceberg represents our analytics platform, and our clients, so data scientists, most of the time, care mostly about the tip of this iceberg. So all the other parts should be essentially transparent for users. That means that, okay, we have a platform, we are limited to the available data in the platform. So the process of getting access should be painless as possible. There should be like a quick way to get the computing resources, and that should support some kind of a declarative API. You need to structure your code as a machine learning pipeline, and need a way to orchestrate that also in a transparent way. And you basically need a scheduling capabilities over here. And yeah, as a data scientist, you are working in a team, so you need a collaborative tools basically to track the work you are doing, and kind of versioning capabilities of your artifacts to provide reproducibility of your experiments. And yeah, most of the time, data scientists don't care about deployment, and yeah, we need to think about the way to automate this process. And in the end, there is this work done by the data scientists. So it's about the feature engineering, and in the end, it's about the modeling things. So you choose your favorite library and describe it in your experiments in terms of a Jupyter notebooks or some Python code. Okay, so how that is perceived by the data science communities? There's no silver bullet for the ML projects. So a lot of things happening around. There's this question in the center of the slide from the data scientists asking about secret weapons which could probably simplify their work. So on each stage, you would expect like a different functionality to be available, which requires different skill sets. So some people try to create kind of a general catalog for different machine learning tooling. You can find this link below. And yeah, here it is, our case study in wholesale banking advanced analytics. I would say we are still early stage adapters, but the graph presents our way to MLOps, where the ultimate goal is to deliver our products to customers faster. So we start with the basic design of our experiment. Then we would like to track our runs, hyperparameters, models, and scores with MLflow. I will be talking about the details of this tooling in a minute. And then from this notebooks, we move to the structured pipelines using Kedro. And on this stage, we need to validate the model. So we need to compare the accuracy, precision, choose the best performing model, and push it to model registry. And yeah, apart from actually the model registry is also provided by the MLflow. And apart from the release artifacts, it can also contain the data quality reports. So there is this nice library from my colleagues from WBAA, which is called Popmon. It is open source and available through the GitHub, so I encourage you to have a look on that. So we essentially want to create this report as the artifact inside the model context. For the release part, we expect to freeze our model, so assign it a version and release it as a Docker container or Helm chart, as we are working on the Kubernetes environment. Basically, we are cloud native, and that can be also like just a serialized model with the metadata stored in some shareable way. Then we apply the 4 I's principle, get approval from manager, and promote our model through the GitLab CI/CD pipeline. It's not yet in place, but we are still working on that actively. Then on the operations side, we essentially deploy it as a Kubernetes resource to do the real-time predictions and explanation, or deploying that as an ML pipeline for batch scoring. In the end, we would like to test our model with the production traffic, monitor the performance, detect data drifts and concept drifts. And as a last part, as our model is on production, we can make this model to be discovered by the other people in organization by using the Apache Atlas and Amundsen on top of it. I will be talking also about it in a minute. So essentially, it's about how much data scientists should care, or how much infrastructure should care. As you can see, like, this is the collaboration of different peoples, and basically we need to provide a split responsibility, so to let people do their job. So let's take a closer look on the tooling part, which is presented here. MLflow. That is 2 major components. MLflow tracking server. It provides the capabilities of reproducible experiments, trackable runs, and while you are doing the model training, and all the metrics, artifacts, and scores. And the second component is model registry as a service to register version, stage, and promote your models. So MLflow to rule them all. It provides the portability, so being able to share artifacts between team members and support multiple flavors of your model, like TensorFlow, like sklearn, and basically the most popular one. It also supports different serialization formats. The basic functionality is a pickle file, which is quite general, but we also think about MLLeap as another level of indirection for serializing the model. So we support this idea to try something locally inside our platform. So from user session, we would like to provide opportunity to promote your local model to the collaborative MLflow instance. That basically is the instance which is used by the entire project, by the entire team. And you have to be aware that Databricks open source that, but there are certain restrictions about MLflow. There's no multi-user and no user management in the community version. Basically, you need to provide it by your own. For the machine learning pipelines, so Jupyter Notebooks is not a great place to structure your ML code. So we would like to, so we actually leverage the Kedro framework to wrap our ML code into a pipeline. So that structure ML pipeline is built around the basic abstractions, which is called a node in Kedro. On the left, you can see the actual visualization of Kedro pipeline using the Kedro CLI and Kedro Vis library. There's also a data catalog available to track the state of your pipeline on different stages, and you can basically rerun only the certain nodes of the entire complex process. You can actually export your Jupyter notebooks as the nodes of Kedro. And there is also a nice template engine, which is called Kedro Starters, and we are building the custom ones for our needs. Unfortunately, I don't have a time to present the demo part, so I will just skip that one and move on. The last thing is that Kedro also provide the deployment part, so you can basically export your pipeline as a Airflow DAG, and this gives us opportunity to schedule our process in an automated way. It also supports the integration with Kubeflow. On the operational side, so we deploy the model for the real-time predictions, and so what we expect here is to just pick the existing model and deploy it with one click with declarative API to parameterize it. So Seldon Core which is available as a Kubernetes operator, is a bunch of services and custom resource definitions crucial to make this deployment automated. So it is a serving layer for our model. So we expose this model as a service. It also provides a ability to do the A/B testing through the shadow deployments on productions. And additionally, it gives us a model explainability with a Seldon Alibal library, which supports multiple state-of-art interpretability algorithms. And on the operational side, we basically monitor. We would like to monitor that also on the Kubernetes environment. So Seldon Core provides set of components for data drifts, concept drifts, and outlier detection. It provides the basic capabilities to monitor your models in action. And this anomaly detectors can be run as a standalone models. So there's kind of a unified interface, and it also provides the Prometheus exporters. And the last part, which I'm quite excited of, is ML governance and discovery. So many organizations suffers from lack of visibility over the ML assets delivered by the different teams of data scientists. And such model catalog would improve the collaboration within the organization through a single interface to discover available data and ML resources and related metadata. So different kind of the metadata can be recognized at various stages of the ML projects. And Atlas is designed for the ML governance, but not for the ML discovery. And Amundsen on top of Atlas is a way to provide a catalog of ML assets. And this is particularly interesting as being the Apache Atlas contributor. And so I also created the recently the RFC to support this ML entities discovery in Amundsen. You can basically have a look on that discussion. So to wrap it all, this is our roadmap. Some of these components are already working, especially the one which are mentioned on the exploration side. And there are multiple dimensions for this architecture. So we are moving from the explorations to operations, where the different compliance rules and risk applies. So essentially, we are moving from the data to the model. And so for the exploration part, we would like to provide as a part of the platform to a way to validate according to recent standards, to make a feature extractions already there, supported with the Jupyter notebooks. You can do the actual training and model evaluation with the support of the MLflow tracking UI and model registry. And then we are moving from this notebook to the structured pipeline. So Kedro is also available on the exploration side. And this gives us opportunity to schedule our process in an automated way, which can be integrated with Airflow. So then we are moving to the operational side. So we actually want to promote model or artifacts with the metadata. And for the deployment part, there's this idea to use Seldon for the real-time predictions and Airflow for the batch scoring with monitoring performance capabilities. And it is all applicable for the production usage and essentially all open source, with a bunch of integration required. So all of these components can be considered as a cloud native and the basis is the Kubernetes platform. In general, it's not about hiding the infrastructure, but give the combination of tools to navigate this complex landscape of infra components by means of reducing the timelines, ensure reproducibility and scalability. So MLOps is here to remove our excuses not to deploy. I think I'm just in time. So if you have any questions, I will be probably able to answer that.
Thank you, Damian, for the rise of the ML ops. Very interesting topic. I don't see yet any questions. I just received only emails from colleagues of external people were texting me. They were asking if we could share your presentation with them and also your contacts. But on the chat,
Sure.
I don't see anything yet. So if you don't mind, Damian, I'll pass the word to Nicole. Okay. Thank you again, Damian, for your amazing presentation.
Thank you.
So as I said, I would like to introduce Nicole, which is our communication expert, and she would like to share some interesting information with you about ING. And thank you all for being in this call with us. And also behind us, nobody see her, it's Anna. She's always organizing this fantastic StreamYard so that you all can see us. So Nicoletta, the floor is yours.
Thank you, Sam, and thanks everyone for attending our meetup. So I would like to tell you a few things about my team, Wholesale Banking Advanced Analytics, or WBA in brief. So we are a multicultural tribe with top talent from 27 countries. We create algorithmic data-driven products and are known for our unique culture. Since we love experimentation, we love social good initiatives, and perceive ourselves as a family. If you wish to learn more about us, then check out our Medium blog, including a wealth of engineering blogs, but also make sure to check our ING Medium Tech blog with top-notch engineering content from across the organization. And if you're interested in joining ING, you can check our careers path. We have a lot of openings in NLP or machine learning engineering. And for graduates with maximum 2 years of working experience, you can check traineeships openings and be offered a great opportunity for personal and technical development in the front runner that ING is. Thanks a lot, and again, many congratulations for organizing this amazing meetup.
Yeah, thanks a lot, Nicole. So I think since you're seeing Samantha and me popping up, the data engineering meetup. So thanks a lot for joining us this last 1.5 hours. I hope you're inspired, and I hope it gave you a little bit more insights in what we do within ING in the field of analytics, advanced analytics, data, everything. So good to know that we have one edition of the meetup left for this year 2020. So on 2 December, we will host our data science meetup. You can have a look at our meetup.com or Eventbrite to subscribe. And hopefully you will be joining us during this YouTube live stream then again. So thank you for hosting together with me today. I want to try to improve the digital high five.
Yeah. High five, Jess.
It's the right side this time. So thanks a lot, guys, for joining. And we keep in touch and hopefully see you on the 2nd of December.
Thank you. Bye.
Bye, everyone. Enjoy your evening.